Hey everyone, it's Chris. Hope your night skies are clearer than mine are right now. I'm not much of a galaxy imager, usually focusing closer to home on nebulae within the Milky Way, our own galaxy. Even so, every couple years, I'll go after M31 and M33, our northern hemisphere galactic neighbors. I capture Bode's galaxy, M81, and the cigar, M82, probably every 3 or 4 years. But I don't remember the last time I imaged M51, the Whirlpool Galaxy. It has to be a decade. So we're in galaxy season until the end of May, early June, and this gives me some time to play around with different scope and camera combinations. I used to treat this time of year as downtime, where I'd be less concerned about missing a clear night or a new moon. Now I treat it as a few months where I can play around with ideas while I wait for the Milky Way to wheel above 30 degrees anytime after sunset. Historically, this was also the time I might do, or the time of year I might do a bit of lunar imaging. But now I think it's also fun to try single target, long imaging runs with shorter exposures. Yeah, and forget about the rules. Forget about the guidelines, resolution, undersampling, oversampling, arcseconds per pixel. Just try out some unorthodox setups for capturing the deep night sky, just to see what happens. So here's a single 2-minute, 120-second sub of M51. This is a screenshot from my old iPad, which is what I usually use with the ASI Air controller. I watched these subs coming through and thought, well, maybe this will turn out better than I anticipated. And it did. Way better. Here's the result of my last run on March 17th. Stacking 115 good frames out of about 148 captured 2-minute subs, all with the Apertura Carbon Star 150, the ZWO ASI 715MC, and an Antlia UV-IR cut filter. I didn't take calibration frames. So I know the stars are pretty wonky around the edges, but I still like the way this turned out. And it's crazy that one clear night and 115 2-minute subs stacked in PixInsight can deliver this image. I used minimal processing, some noise reduction, photometric color calibration, and stretching, then output to 16-bit TIFF. I cropped it and added some annotations in Photoshop, but that's it. So let's talk about this camera for a minute. It's a $230 USD color camera. I bought it a couple years ago. I pre-ordered it when ZWO announced it. The ASI 715MC has tiny pixels, 1.54 microns. It's 4K resolution. It's 3864 by 2192, so around 8.5 megapixels. Pretty basic so far. But the really interesting aspects of this Sony IMX715 sensor are the lowish read noise, obviously important in an uncooled camera, and the relative responsiveness and quantum efficiency. Just looking at the graph provided by ZWO, this sensor is especially sensitive in the red and near infrared. Most of the red bandpass is well above both blue and green. I think that's what originally sold me on this camera. Just wondering how this would work in a super portable rig with a dual narrowband color filter, or with just a UV-IR cut. Well, I haven't really put it to the test until now, and I'm impressed so far. Drawbacks with this setup land squarely on the tiny field of view and resolution of 0.5 arcseconds per pixel. I had serious trouble plate solving. That affected polar alignment. I have a few things to try next time to help with this. 2x2 binning, longer exposures for solving. I'll let you know how that goes. We have a week of spring rain here, so that might be a little while. Once I had a decently stacked image, I started looking at the other objects in the frame. those tiny smudges of distant light, probably galaxies. A few slender bars of brighter color, definitely galaxies, edge on. So I started with the Aladin Sky Atlas. All links are in the description below. I searched for M51, found the small galaxy-like objects in the same area. And if you right-click on them and select "What is this" in the little pop-up menu, you can, it's easy to spend quite a bit of time digging into each of those, but you often find some interesting info, like how far some of these galaxies, how far away some of these galaxies are. So I found info on the object at the lower left in the Lite catalog, which I also think is IC4282. And that's in the 600 million light-year range, away from us. I calculated the 668 million light-years from the Lite distance data, which is in megaparsecs. So the two galaxies just left of the Whirlpool are in the 200 to 300 million light-year range, so still pretty damn far away. But that galaxy at the top, directly above M51, is almost 2 billion light-years away from us. What is crazy to think about is that a bunch of photons, propagating through the intergalactic medium, traveled for nearly 2 billion years from our perspective. They somehow avoided scattering or absorption by any of the stuff between here and there. They made it all the way through the atmosphere on our tiny blue planet to strike particular positions on a camera sensor, transferring that energy to electrons, which then get counted during the sensor read and given a value by the ASI 715's 12-bit analog to digital converter, and then saved in a FITS file. Okay, that's just wild. Capturing 2 billion-year-old light. Yeah, tell me what we're doing, we astrophotographers. Tell me what we're doing with our gear under clear night skies isn't just the wildest shit imaginable. Yeah. So get out there and experiment, everyone. Clear skies.